All right, so now we're recording. So welcome to our CCNP ENCORE class for September 20th. I do apologize again for last week being out. I was sick. I am sick again this week. It just seems like I can't shake. Actually, this is something different than last week. So I've been able to catch two things in 2 weeks. So it is what it is. Couple quick things I want to mention to everyone. Realize I'll show you the syllabus again today and things that were due today. Honestly, our first items for chapters 1 through 4 were due today. There's only about 4 or 5 labs that you need to complete, really 4 labs. So Ada, I know you're just getting started. That was completely my fault. I apologize for not contacting you before the class started. But we'll get you up and going and everything taken care of. That's not a problem. Be aware that the new CCNP, which is what we are studying, and it's what we're using for our information, is the new exam starts today. So basically from here on out, you must use the CCNP ENCORE, the new exam. And so that's a good thing, because like I said, that's what we're actually prepared for. So be aware when you go into our class and you look at these 350, 401 ENCORE PDF, when you look at these exam objectives, this is the new 1.1 objectives that started today. So we are in fact preparing for the 1.1 exam. Okay. The other thing I want to stress again, I have one of my coworkers who's actually going to take this exam next week. And like me, she's stressing out. And the reason is, you look at the book, and remember, our book is, we go into our O'Reilly Online, and I don't know why they got rid of the A to Z up here for some reason, but they did. Scroll down to O'Reilly, and then log in using your Stanley email address. And we've got a video in here showing you how to do that in the class. But remember, we've got this new 2nd edition book that is not even published until October. So we're actually working on the 1.1 book, and we're looking at the 1.1 materials. So be aware of that. But if you look at the book has a huge amount of information. All right. So if you look down through here, everything from multiple different advanced BGP, multicast, advanced OSPF. There's a great deal of information in this book that is not on this exam. So make sure when you're studying for this exam, don't do like I did. It took me a full year to feel like I could go take this exam, because I kept studying that entire 1,000-page book, when if I would have just taken this exam objectives and known the objectives, I could have passed it a lot earlier, a lot sooner. So make sure you're using these objectives as you're going through our readings. Know what the CEF is, the Cisco Express Forwarding Table. Know what the CAM table is, Content Addressable Memory Table. What the tertiary CAM is, how the FIB is used, all of those. That's all in chapter 1 of our book, Bob. But make sure you do that, because if you don't, you'll be like my coworker and like me, and that is, you'll be driving yourself nuts thinking you've got to learn everything in that entire 1,000-page book, and you do not. It's not what you have to do. The other thing I want to make sure everyone's aware of, and I hate to admit how long it took me to realize this. It actually took about 5 years ago or 7 years ago, when I started working on with a company to create an exam. I helped to create an exam. And that's when I started paying attention to these verbs right here. So if it says configure, make sure you can do that. Make sure you do all the labs on VRF, virtual routing and forwarding, and on GRE and IPsec tunnels. Make sure you can do that. Make sure you know how to do eBGP between directly connected neighbors. So simple OSPF 2 and 3 environments. Okay, so just pay attention to those. Configure NAT-PAT, configure HSRP, all of those. Make sure you know how to do those things, because that will definitely show up on the exam as an item. All right. Any questions on what we are covering for this class? Okay. Everyone's done their introductory assignment. Thank you very much. I really appreciate that. Everyone's already enrolled in our NetACAD class. What I really want to do today is I want to look at MST with you a little bit. Now, first off, before we go into MST, it's important for me to talk a second about spanning tree. It used to be back in the old days, and that's kind of funny because it was back when there was 4 CCNA classes. We actually covered spanning tree inside of CCNA. So what is the purpose of spanning tree? Can anybody explain to me the purpose of spanning tree? Basic spanning tree, not MST, basic spanning tree.
To not have a loop at layer 2.
Yep, stop loops at layer 2. That's its primary purpose. Now, remember, if you look at a frame, inside of a frame, there are no timeout or time to live mechanisms. If you go up to layer 3, you've got the TTL field, time to live field. But if you look at frames, there's no TTL field. So if you get in a loop, you can very quickly end up with what's called a broadcast storm, and you can bring your entire network down. Spanning tree was introduced to fix that. So let me see if I got packet tracer on this thing. So what happens if you end up with 2 switches or 2 bridges? By the way, bridges and switches are the same thing. Bridges are the old name for 2-port switches, and then switches are just a bridge with multi-ports. All right. But if I come in here and I pull out a switch, and I pull out another switch, and I connect 2 different cables from, let's say, gig 01 over to gig 01, you'll see it's going to be down for a little while. All right, because one of the first things it's going to try to do is it's going to run through spanning tree. You'll notice how these are now amber. So it's running through spanning tree. It's doing the blocking, listening, learning, and forwarding. It's actually listening, learning, and forwarding. So for up to 50 seconds, it's trying to determine, am I connected to another switch or am I connected to a host device? Now, we've talked about and studied, and you will have studied in this once you do your reading if you haven't already. In chapter 3, you'll learn about PVST, per VLAN spanning tree, a rapid spanning tree, all of the older or all of the other and older versions of spanning tree. But basically what happens here now, if I go in here and I put a secondary link, you'll see it's going to go through spanning tree. And eventually what's going to happen is one side will come up, but the other side will stay down. And that is because it's going to block the loop. It's not going to allow a loop to take place. That is the purpose of spanning tree. Now, many times people get confused and say, why does it bring one side up and block on the other side? Well, you have to understand that is because of the historical nature of Ethernet. Ethernet used to be bus lines, bus cables. So if one side was up, okay, these switches can't promise that there's not a PC sitting out here in the middle. I mean, we could, and it would be very crazy to do this, but you could technically put a hub out here. All right. That's an access point. There are hubs in here. You could put a hub in here. And with this hub, so I could put a hub in here. And I could actually do this. So I could get rid of, let's get rid of this line right here. So delete that line. Yeah. Let's go put, and we'll go from here, gig 02 to the hub. Actually, I can't do that because it doesn't have that Ethernet. We'll do a secondary. We'll do a fast Ethernet because we don't have a fast Ethernet. The fast Ethernet, and we'll go here. Now, what should happen is the exact same thing should take place that happened a second ago, and that is you should end up with, on the right-hand side, you'll have a forwarding port. On the left-hand side, you'll have a blocking port. All that's done, remember, by the bridge ID. Lowest bridge ID becomes the root bridge. I could put it in simulation mode and fast forward, but it's only 50 seconds, so I'm not gonna do that at the moment. But you'll notice what'll happen is this is perfectly valid. So we could technically, although it's highly unlikely, you could technically have a PC actually connected out here like this. And because of that, spanning tree has to have across all Ethernet links at least one port that is forwarding. All right. So we go in here and we look, we'll go in our CLI, we do a show spanning tree. And you'll see here we're running IEEE per VLAN spanning tree. You'll see that this bridge is the root for VLAN 1. And you'll notice too, if I was to create another VLAN, you would have a spanning tree instance per VLAN. Now, that's perfectly fine in environments where we have 5, 8, 10, even 20 to 25. Now, getting up in 2025 is getting a little high, but it's still not bad for having spanning tree instances. But if you get up in an environment with hundreds of VLANs, you can have an environment where that amount of spanning tree is actually affecting the processor on your switches. So what was developed was a thing called multiple spanning tree protocol, which allows you to create, instead of a one spanning tree instance per VLAN, it allows you to group VLANs together into a spanning tree instance. Now, excuse me. So if you had 10 VLANs, you could put 3 of them in instance 1, 3 in instance 2, and then 4 in instance 3. And then that way they would appear to be their own spanning tree instances. If a port went down or something happened inside of that spanning tree instance, it would not affect the other spanning tree instances in terms of having to do recalculations. They also have the ability to load balance by saying that for this group of 4, I'm going to allow switch 1 to be my bridge, my root bridge. For this group of 3, switch 2 would be my root bridge. And for this group of 3, switch 3 would be my root bridge. So instead of having a common spanning tree topology, we end up with, which would be this again, we end up with a common spanning tree instead of a per VLAN spanning tree. Then switch only has to keep up with one set of spanning tree information, and technically it keeps up with at least 2 because there is an instance 0 that all ports are part of as part of MST or multi-VLAN spanning tree, but our multiple spanning tree protocol. Sorry, I always said I'm sick. But MST maps one or more VLANs into a spanning tree instance called an MST instance or an MSTI. Now, there's always an MSTI 0 instance, and all other spanning trees actually, their information rides inside the MST 0 instance. The MST 0 instance by default is where all ports are part of it to begin with. All right. You understand why we would want a common spanning tree versus a per VLAN spanning tree? Are there any questions on that? All right. So we end up with a group of switches together in MST region. The great news is it's actually compatible with our PVST, our normal PVST and rapid spanning tree. Completely backwards compatible, because what happens is the MST region appears to be one big spanning tree to the other types of protocols. Now we'll talk a little bit about some instances that can cause problems, but for the most part, it is very much backwards compatible. This special instance 0 called the internal spanning tree is always the first instance, always runs on all ports. And it is also where the BPDUs are actually transmitted. So when you look at a BPDU for multi-spanning tree, you'll always see MST 0. And then if there are any other MST instances that you have created, you will see them inside of there. In fact, it's actually strongly suggested to not put any of your VLANs into MST 0 for their actual instance, because it can cause some problems. Now, by default, you can have up to 16 instances, and that depends on your switch type and the iOS that's on the switch. But that is the default. Now, configuration is very simple. It is not difficult at all. You put in spanning tree mode MST. Now, if more than likely, I'm not saying you have to do this, but more than likely, you're going to convert all of your switches to MST if you go to MST. You don't have to, because remember, it is backwards compatible. But you will probably switch them all over. Then you define your instance and the priority. Now, that is honestly just like spanning tree itself. By default, the bridge ID, which is the bridge ID of the switch, which is found how? Can anybody tell me what the bridge ID is? You might remember the default bridge ID. Anybody remember?
It's MAC.
Close. It's 32768 plus the VLAN ID plus the MAC.
My goodness.
So it's 32768. We'll put that in chat. Plus the VLAN ID plus the MAC. Now, what ends up happening then, if you don't change anything, change nothing at all, what's going to end up happening is the MAC address is actually going to be the delineating factor. It's going to be what determines who's the root bridge and who's not. So whoever has the lowest MAC address will end up being it if you don't change the default priority. So don't miss that question on the test though. If they ask you how the bridge priority or how the root bridge ID is formed, it's not the MAC address. It's 32768 plus the VLAN ID plus the MAC address. Now, if you change this priority number to anything below 32768, and by the way, you do that in increments of 4096, that will actually allow it to become more likely to be the root bridge. You can also put what is called spanning tree mode MST instance number 1, 2, 3, whatever, root primary. If you do that, sorry, everybody, root primary will actually try to set that particular bridge's ID to 4096 less than any other bridge ID it sees in a BPDU. So that's an important concept. You need to control who is your root bridge, because you don't want, if you don't change these priorities, typically the older devices in your environment have the lower MAC addresses. And so you could end up with some 1900 switch sitting in a closet somewhere, the root of your network, and that's very inefficient for spanning tree. Okay. By default, you'll see all the VLANs are associated with MST0. And then you have to go in and change it to be part of another one. Now, this is a little confusing, but it is important to understand. When you go in here and you make your mode, spanning tree mode MST, they've set this particular bridge to be the root for all instances that they're configuring on this particular device. And then this revision 2, this revision number is if you make changes. So let's say I first put in instance 1 VLAN 10, 20, and 99, and then I wanted to make a second instance, you would change that to revision 2. Okay. This will ensure that all of your MST routers, or not routers, excuse me, MST switches are using the correct information for their instances. Because if someone has a lower revision number, the higher revision number will take precedence. But you'll notice what they've done here is they put VLAN 10 and 20 into instance 1, VLAN 99 in instance 2. So now there are technically 3 spanning trees. There's one for instance 0, there's one for instance 1, there's one for instance 2. But instead of having 4 spanning tree instances, we've gone to 3 because we put 10 and 20 together. You then can see show spanning tree MST configuration. It'll show you your name, show you the revision, number of instances, who is mapped to what instance. Then you can even drill down further and see the actual information about each individual instance. Remember, there's no way to get rid of instance 0 because it is always there. And you can also even drill down into the interface and see what the interface is set to. Is it a 40? Is it a root port? Is it a forwarding port? Is it an alternate or a blocking port? You also, through this command, the show spanning tree MST interface, you can see whether or not BPDU filter and BPDU guard and other items have been set on the particular thing. So here, show spanning tree MST, you'll see it's the ports on this particular switch, switch 3, are set to forwarding, blocking, and forwarding. The alternate is just a block port. And it's really pretty simple. There are some mistakes you can do though. MST has, because of the fact that everything rides or rides on top or inside of the BPU for MST0. If you, first off, folks, this is an insane idea right here. No one should connect their switches together with access ports. All right. This particular problem is only going to happen if you connect your ports with access ports. And what they've done is they've left VLAN 10 as part of instance 0, and they got VLAN 20 in instance 1. Well, VLAN 10, because we've got a loop here, what's spanning tree going to do? It's going to block one of these. And it ends up blocking port 02 because of the spanning tree. It still follows the exact same rules. The lower port is a better port, so that becomes the true link. Well, because VLAN 10 is only set to go across the bottom link here, or instance 0, it will be blocked and you won't be able to connect. PCA, PCB won't be able to talk to each other. How do you solve this? Don't put any of your VLANs that you want to actually move traffic on in instance 0, number one. Number two, use trunks. I mean, that's one of those things where if you're not using trunks, it's kind of crazy. So use a trunk. Does that make sense as to how this could be a problem? I think it's just a very poor design anyway. I would never connect two of my switches in my environment with access ports. Okay. The other item that can take place is pruning. Now, in a spanning tree environment, many times we do VLAN pruning. In other words, if a VLAN doesn't exist on a switch, we prune it out. So we don't even run a spanning tree instance because we don't need it on that switch because there are no ports in it. But what happens is if you do pruning, especially if you depending on how it works and how your different VLANs are set up, you can end up by pruning making certain VLANs inaccessible. So a simple rule though is to only prune all the VLANs in the same MSTI for a trunk link. So in other words, if they're in the same instance, you can prune them. A better thing I've actually read is just don't do pruning when you're running MST. They actually say that that's probably a better idea, is don't prune when you're running MST. So if you end up with an instance where you think you should be able to have connectivity and you don't, check pruning, because it's either going to be pruning or it could be, again, that they've got this crazy access port set up. If you see any question on the exam that's got access ports in MST, it's automatically pretty much going to be the answer is you've got to move the VLAN off of instance 0, or do trunking, one of the two. The other thing I talked about earlier is I said MST is backwards compatible. So there's really two simple rules when you are going to run MST with other versions of spanning tree, and that is either make spanning tree the root bridge, or make MST the root bridge for all of the VLANs in their environment, or make the external spanning tree the root bridge for all of the VLANs in the environment. It's either or. So you can't mix and match. So if a VLAN is inside of MST, you either say every single VLAN in MST I'm the root bridge for as part of this MST instance, or you say everything outside, all the root bridges are outside of my MST region. All right. Now, that's what they're showing here, basically. If it is the root bridge for all boundary ports, they'll flood the same IST instance to all the other VLANs. In fact, here's what actually happens. This is kind of crazy. But what MST does, because remember, and there's a picture in the book, but there's not a picture in these slides. If you'll remember, there's actually, when you look at a BPDU, there's the MST0, and then underneath MST0 is all the other MST instances with their information. Well, whenever MST has to interface with typical spanning tree, per VLAN spanning tree, what it simply does is it pulls out that information underneath MST0 and builds a per VLAN spanning tree information to send out to the per VLAN spanning tree group that's outside of it. So again, either make it the root bridge for all of the VLANs in its region or no root for any VLAN whatsoever. That's really pretty much a simple thing. Now that's called PBST simulation check, and it is actually how MST interacts with per VLAN spanning tree. Now, notice one of the things here about getting prepared for the exam. Here's our key topics, key terms. Here's our references. So each of these slides in here has all of this. I know, Ada, you are new to the class. So one thing I do want to make you aware of is inside of NetLabs, I put you in a class. And in this class, well, I had it until I got logged out here. Inside of this class are all of the labs for our class. And typically when you do a lab,
Yes.
you will see like this MST lab. When you schedule it, there's only 3 pods, unfortunately. We've only got 3 pods. And I would say I would schedule at least 2 hours for every lab you do, minimum, because these labs are a little bit longer than some of the others. Now, if you get done early, just end your reservation. But when you go into the lab, you're going to notice, if you've never used NetLabs before, there's a content tab. And on that content tab is a document that you must use whenever you're doing a lab inside of NetLabs. It even says this has been rewritten for NetLabs. However, what I did was, just to make life easy for you, I went in and I took all of these PDFs, okay, and I converted them into Word documents. And so they are actually sitting right here as Word documents. So you just download the zip file, you can open up the Word documents, and you can use that to do your lab. You can also use it and upload that whenever you complete a lab. That's what needs to be uploaded right here, and that is your document. And that tells me to go check your lab inside of NetLabs. Now, every command you type is saved in NetLabs, so I don't have to have configurations. I don't need any of those things. You're welcome to put them in there if you want to, but I don't have to have them. The other thing I did for you is I created a zip file that has all of the initial configs in text documents or text files. So when you're in NetLabs, it typically tells you to load these items right here, starter. Well, if you try to copy this, it's going to have all this junk in the middle here. I've already fixed that for you. All of those are existing already in class right here. So you can download those, open them up, and then you just go into the device, and once it's done loading, now it takes them a little while to load. It takes about 10 minutes for them to load, but you can always go in here and do paste the terminal. And when you do, you can actually paste in those text files that I had so that you don't have to type all that information in on the lab. So you don't have to type all this. You don't have to try to copy and paste it out of this document. I've got all of those already right here in your initial device config files. Okay. I also set you up some notes down here. These are just some little notes that I put together. Just a little thing that I grabbed out of some other study materials I had, and it just gives you a quick overview of MST. So make sure you take a peek at those and use that as part of your study. All right. Are there any questions about MST? Notice, folks, that we have 3 labs basically due today. That's all we had to do. We've been in class for 2 weeks, but I didn't do a whole lot in the first 2 weeks to make sure you were able to get caught up. Next week, we've got a couple labs due through 6. Okay. So you basically have 4 labs due next week. So you need to be reading through chapter 6 on the book. And remember, our book is inside of O'Reilly, and it is completely free to you. It is, again, this book's not even published yet. This book comes out in October, October 30th, in fact. So the only way you can get this book right now is in an ebook like this. But you can go in and do all the reading, and then you can go in and get your labs completed. And then actually today, if anybody tried to do a test, if anybody tried to actually do the chapters 1 through 5 test, it was not on inside of NetAcad. I did turn those on today. So all chapter exams are turned on inside of NetAcad. Right. Any other questions? Any questions on any other of the items that we were in the first couple chapters? First couple chapters, by the way, chapter 1 was looking at basic routing, what a router does, the different databases. Chapter 2 was like static routes. Chapter 3 was looking at just basic spanning tree, regular old spanning tree. Are there any questions on those? Again, these are labs you would have done, just simple inter-VLAN routing, STP. This lab, by the way, is more of a look and see lab than anything else. It's not really there's not a lot of configuration in lab number 2. And even lab number 4 is not a very long lab. And then we'll get into VTP and we'll get into either channel. You'll notice we're doing either channel again, which is something we've done inside of CCNA, but we're doing it some more. We've also got static routes, then we're going into OSPF. Okay. Any questions? I'm actually going to cancel this reservation because I don't want to keep one of these pods open when I'm not actually doing the lab. So notice I just went up to reservation and did end reservation, and boom, it ends. Now what happens is it does take about 10 minutes for everything to be erased and reset, and then the pod will go back and be available for the next user. Do you have any questions for me?
No, thank you.
David, Eddie, anybody? Everything good?
Just a quick question. What should we have to upload as a document for the labs?
Hold on, I couldn't hear you. Try again, Ada.
What exactly we have to upload as a document for the labs?
The document you need to upload is hold on one second. The document to upload is the actual document for the lab itself. So like I said, inside of, let me show you. If you download this NetLabs doc file, this one right here, my machine is doing screwy stuff. You will have the Word documents. You upload that Word document. Just put your name in the front of it and upload that.
Okay.
And what that really tells me is you did the lab. Now, if there are any questions in the lab, if it asks you any questions, you're required to fill those questions out and include that with your lab upload. But that is what you upload.
Okay, thank you.
And that gives me, again, tells me that you've completed the lab, and I then go and check it, and I can look, like I said, inside of NetLabs and see everything you've typed. Okay. Good question. Any other questions? One quick thing I will mention again, don't forget, our syllabus is here in this simple syllabus. I also have it in a Word document up here. But in simple syllabus, you will see the requirements for this class. We are not expecting you to do every single lab. For this class, you are expected to do all of the chapter exams. So you do have to take all the chapter exams inside of NetAcad. You pick and complete 25 labs minimum of your choice on netlabs.stanley.edu. You must make a 75 or higher on the final exam, and you must do the final skills exam on my NetLab system. So you're not required to do every single lab that I put in there as an upload. If you feel very confident with static routes, don't do the static route lab. If you feel super strong on spanning tree, don't do the spanning tree. But you've got to do 25 labs. If you don't, you will not get credit for this class, and I will not accredit you. Okay. The other thing that's super important about this class is if you do finish this class, it does give you CE credits. It gives you credits towards renewing any active certifications. Now it's active certifications, not certifications that have expired. And this class gives you the most of any that we have. And that is basically CCNP Enterprise Core will give you 64 CE credits. It only takes 30 to renew your CCNA. If you happen to have your CCNP, it will not be enough to completely renew your CCNP. You actually have to take both Core and ENA RSI in order to get enough for those. So I will send this, well, I don't have to send it to you. This document sits inside of the class. So if you want to review about these CE credits, sitting right here, you can review those. But you will not be accredited for this class if you don't do, there's 25 labs, all the chapter exams, and the written final and the hands-on final for me. Okay. So what I want you to do, if you have not completed the labs for chapters 1 through 4, go ahead and get those done and do the reading for 1 through 4. Go ahead and start your reading for 5 and 6 and get those completed, and work on your labs that are due next week, which are the labs for 5 and 6. Be aware, I do not typically handhold you about reading. If we're on section 7 or 8, you should have read section 7 and 8. It's that simple. So we're, I don't handhold you on the reading. If we're covering a particular area, or if an area is being covered that week by the class, you're expected to have done that reading. Okay. Any other questions? I cannot get my downloads to work on my computer, so I can't show you the documents. But any other questions? Okay. Let me stop my sharing. All right. I'm now going to stop my recording.